result we have for characterization test, for the test according to the aeronautical standards. We measure the heat release rate, the optical density, the flammability of the materials, and also the toxicity, the concentration of different gases. So, well, mainly PNC 6 and 7 are the carbon fiber with this melamine resin, and you can see that they have the better results in heat release, also in optical density, and with less concentration of toxic gases, especially in sulfur dioxide. So the melamine resin present the better behavior comparing with the epoxy fabric and epoxy tapes. So, well, those are the main conclusions they have remarked. And, well, after this characterization test, we manufacture curved panels to be tested in the scale demonstrator. We test the same materials, carbon fiber with epoxy tape, carbon fiber with epoxy fabric, and carbon fiber with melamine resin. And we compare these composite materials with aeronautic aluminum alloy. So the main result we have is that the composite material avoid the penetration of the fire in the case of an external fire. So the resin burns, but the fibers maintain the capability to act as a barrier to penetration of the external fire. In the case of the aluminum, as we know, when the melting point is reached, all the fusion melts and the fire penetrates inside the aircraft cabin. So we are going to see a video with comparison of the different results. It hopefully works. So this is the test in the scale demonstrator. In the top side you can see a external view, and in the bottom side you can see a comparison between the aluminum, epoxy, and melamine. So well, we start with the ignition of the fire pan, and well, after 1 minute of starting of the flame application, you can see in the epoxy composite how some bubbles appears in the cold surface of the specimen, and when these bubbles explode, a big amount of smoke is generated, and you can see how in 1 minute and a half most of the interior of the cabin is full of smoke. So the 2 minutes and a half, the aluminum composite it start to melt, and when the aluminum fuselage melts, the flame penetrate inside the cabin, and the smoke generated in the kerosene combustion also penetrate. And well, it's quite clear the difference between the epoxy resin fiber composite and the melamine. So here is the fire penetration in the aluminum fuselage, and well, all the smoke generated in the kerosene combustion enter. So after 3 minutes of the test, we extinguish the flame. That's well, it's quite clear the difference in the smoke concentration between the three different materials. So that's the review. So, well, we're going to see now the main measurements and results we have during this test here. Well, you can see here the maximum temperature that we measure with the thermocouple 3. We have inside the cabin, so we reach around 90 degrees. Well, with the aluminum fuselage, once the flame penetrates, you can see how there is an important increase in the temperature. This is the temperature in the cold surface of the composite materials. We have around 400 degrees in the cold surface of these materials, and this is the temperature distribution in the thermocouple 3 inside the cabin. So I'm going to go quite fast. This is the concentration of different gases for all the materials that were tested. Here also we can see again how the PLC 5C, which are this melamine resin, has the lower toxic gas concentration. It's important to say that in this study we only have taken into account the composite fuselage skin, but other interior materials or thermoacoustical insulation has not been considered. So here there are some graphs again for the small toxicity concentration of the different material tested. And well, some conclusion of this study. As we have seen, the carbon fiber, these melamine materials, present the better fight performance, but they must be restricted because of their penalty in the weight and because of the high cost. So, also, the fuselage made in composite materials protect the cabin against flame penetration, but they have the problems of the smoke generation and toxic gases generated during the combustion. So, further investigation should be performed to obtain better materials, candidates to be used as fuselage skin. Good insulation should be established, and they have to be defined if any specific standard has to be applied for these composite materials. So well, this is more or less the same. Further research related with this work. So thank you for your attention. If you have any questions.
Questions, please, over there.